Welcome to today's on-demand webinar about Ashland's new cellulose gum grades designed for blending with Guar gums.
The first part of this presentation reviews Ashland, as over the years it has dynamically changed with the sale of the Ashland distribution business and the acquisition of ISP, or International Specialty Products. Then we will review the current Ashland Specialty Ingredients food portfolio. Finally, we will focus on our new grade in our cellulose gum portfolio, Aquacel GSH.
Today, all of our Ashland businesses hold leadership positions within the markets they serve. We have three specialty chemical businesses: Specialty Ingredients, the #1 global producer of cellulose ethers and a global leader in vinyl pyrrolidones; Water Technologies, the #1 global producer of specialty paper-making chemicals; and Performance Materials, the #1 global leader in unsaturated polyester and vinyl ester resins. We complement these specialty chemical businesses with the high-margin consumer markets or Valvoline business, which holds the #3 spot in passenger car motor oil and is the #2 franchised quick lube chain spot in the United States. Our regulated businesses, including food and beverage, now falls under Ashland Specialty Ingredients. The combination of Ashland Aqualon and ISP strengthens our position in food and beverage applications, as well as in pharmaceutical excipients and personal care. On the previous slide, we summarized the global presence of Ashland worldwide. This slide focuses specifically on the global network of scientists that now exist within Ashland Specialty Ingredients. The addition of ISP significantly expands our R&D footprint outside North America by adding development labs in the UK for acrylics, in France for skincare, and in India for pharmaceutical excipients. It quadruples our patent portfolio, triples our team of research and development scientists, and expands our ability to deliver industry-leading innovation and solutions in a number of important high-growth end markets, particularly those in personal care, pharmaceutical, food and beverage, and energy. Together, our approximately 500 world-class scientists will focus on developing new chemistry, market-changing technology, and customer-driven solutions at key centers in the Americas, Europe, and Asia. We also collaborate with academia and private industry in a wide range of scientific disciplines. Our desire is to deepen the relationships we have with existing customers and to build relationships with new customers in need of end-to-end solutions. Ashland is a world leader in cellulosic food ingredients. Our premium additives and stabilizers enable healthier, tastier, and more convenient foods. Our solutions provide an array of functional properties, including thickening and rheology control, stabilization, water binding, foam promotion, thermal gelation, structure enhancement, and improved mouthfeel. Since the 1950s, our ingredients and expertise have enabled formulators to break new ground in food and beverage performance in a wide variety of applications using our broad portfolio of products, which include Aerowhip and Klucel hydroxypropylcellulose, Benecel methylcellulose and hydroxypropylmethylcellulose, Aqualon, Blanos, Bonwell, Aquasorb, and Aquacel Cellulose Gum, and Supercol Guar Gum. Aquacel, Aquasorb, and Bonwell are cellulose gum products. Ashland's cellulose gums are very versatile and come in many grades, viscosity levels, and particle sizes. Examples of cellulose gum applications are enhanced texture and mouthfeel, such as in beverages, improved protein stabilization as found in low pH or fruit-flavored dairy beverages, and longer shelf life via water control and water retention in bakery applications and desserts. Benecel methylcellulose and hydroxypropylmethylcellulose offer unique properties including thermal gelling and binding. Thermal gelling is useful in meat alternatives such as veggie burgers, in meats such as sausages, as well as in gluten-free baking. Thermal gelling is the primary driver in why Benecel methylcellulose reduces oil pickup in batters and coatings, as well as in other fried foods. Benecel methylcellulose is used to stabilize fillings, such as in filled baked desserts and savory applications. It also provides thickening and texture in sauces. Aerowhip and Klucel hydroxypropylcellulose are very unique hydrocolloid products that have the exceptional ability to promote and stabilize foams, such as in dairy and non-dairy whipped toppings. In addition, Klucel hydroxypropylcellulose is a terrific film former and is used in specialty candy coatings. Ashland has launched a new product to help supplement or replace Guar, Aquacel GSH Cellulose Gum. This cellulose gum offers cost-effective alternatives to guar for beverage, dairy, and other applications at a time when they are needed most by these markets. Aquacel GSH Cellulose Gum exhibits the greatest synergy with guar while retaining the advantages of cellulose gum. Aquacel GSH Cellulose Gum is clear in solution, quick to hydrate in both hot or cold water, and has very low microbial counts. Volatility in guar availability and pricing has left food manufacturers scrambling for a replacement. In the U.S., guar gums are being used in the oil and gas industry for lubrication. While using guar in this manner is not new, the horizontal drilling process is relatively new and demands far more guar gum. Further, oil and gas industry demand shows no sign of abating and could continue to increase if other countries adopt this practice. It is well known that blends of cellulose gum and guar gum will exhibit synergistic viscosity. Previous work in this area has been conducted in our laboratories with individual polymer solutions being made at 1% and then blended together. This work showed ratios of 80-20 blends for best guar cellulose gum synergy. While this was an effective way to ensure accurate data on viscosity, it is not practical to how our formulators use these ingredients. The current work that we are presenting today is a more practical application using simple dry mixing. Based on this work, we are launching a new grade, Aquacel GSH Cellulose Gum. With this grade, synergies have been demonstrated in guar cellulose gum ratios ranging from 70-30 to 40-60. This maximizes flexibility when adding cellulose gum. The mechanism for hydrocolloid synergy is explained as the formation of associated junction zones between lengths of unsubstituted areas along polymer backbones, promoting interpenetrating polymer networks. The network basically builds through polymer-polymer associative behavior. Extensive testing took place to determine optimum use levels and ratios of guar gum to cellulose gum. The total hydrocolloid use level was 0.5% for better mixing and reduced air entrainment. The guar gum and cellulose gum were added directly to water and mixed well. Viscosity was then monitored at 30 minutes, 2 hours, and 24 hours later. The greatest viscosities were seen with Aquacel GSH Cellulose Gum and guar. Looking at this chart on the left side is the results for 100% guar gum. The results on the right are 100% cellulose gum. In between, along the x-axis, are the various ratios that were tested, with the first number being the amount of guar and the second number being the amount of cellulose. This chart clearly shows that the combination of guar gum and Aquacel GSH Cellulose Gum produces a synergistic viscosity that is much higher than that exhibited by the combination of guar gum and a typical high viscosity cellulose gum. Another key finding from the testing is that the viscosity of blends of guar and Aquacel GSH Cellulose Gum were similar across a wider range of ratios than previously reported. This chart is showing how guar and Aquacel GSH Cellulose Gum blend ratios of 70-30 to 40-60 all exhibit high viscosity. This gives a wide working range of blend ratios where the synergistic viscosity can be leveraged in formulations. In addition to overall synergy, analysis of blend dosages was also conducted. In this chart, we are showing blends of 50-50 guar cellulose gum using Aquacel GSH Cellulose Gum at various dose levels. A 0.3% dose of the 50-50 blend is of comparable viscosity to 0.5% of guar gum alone. Less dose means less overall guar is needed during this supply shortage, and that there is a cost-effective alternative to the escalating price of guar gum. Now that you understand how guar and cellulose gum work together, we will review our recent work in ice cream using Aquacel Cellulose Gum. Guar is used in ice cream formulations to provide texture, melt resistance, control of ice crystals, and stabilization against the heat shock that is common in ice cream distribution systems. The functionalities that guar provides in ice cream formulations are very similar to the functionalities provided by cellulose gum. One drawback to the extensive use of guar is that it has a greater tendency to destabilize proteins during mix aging, sometimes requiring increased use of carrageenan. Cellulose gum ingredients are widely used in dairy and ice cream applications to control water mobility and ice crystal formation during freezing. Benefits of cellulose gum in ice cream include providing stability against heat shock, which is a term used when ice cream is exposed to repeated warming and refreezing. Cellulose gum will protect the texture of the ice cream by reducing the liquefaction during melting and keeping the ice crystals small and even during the freezing process. Cellulose gum also provides the desirable texture found in many high-quality ice creams, described by professionals as chewy. Finally, cellulose gum provides excellent overrun, which is the amount of air incorporated during freezing, excellent stiffness, and will control the melt profile so the ice cream does not melt too quickly. To evaluate Aquacel GSH Cellulose Gum, we performed trials with a formulation representative of ice cream. We formulated for 10% butterfat. To establish that we can substitute guar partially or in whole with Aquacel GSH Cellulose Gum, we measured a number of attributes during processing and as finished products. The mix viscosity was measured after aging. A batch freezing process was used, and during the tunnel freezing, overrun and stiffness were tracked over mixing time. Finished product after hard pack and tempering was evaluated for melt profile and sensory properties and was examined by light microscopy and scanning electron microscopy. An accelerated heat shock protocol was also used to evaluate the ability of stabilizers in managing textural damage from fluctuating temperatures during typical distribution channels. This is the formulation used in the ice cream study. It is a very typical formulation with 10% milk fat. The milk is provided via non-fat dry milk. In this study, the stabilizer also included carrageenan, an emulsifier known as Durham 127, and a mono and diglyceride from Loder Crocklin blended with polysorbate 80, which is a commonly used combination in the North American market. These are very typical use levels of carrageenan, emulsifier, and hydrocolloids. Here, the use of Aquacel GSH Cellulose Gum as a stabilizer is compared against guar as well as a blend of 50-50 cellulose gum and guar gum. The mix was processed using pilot high-temperature short-time pasteurization, homogenized, and then aged overnight. From there, the mix was frozen on a batch freezer, hardened overnight, and then moved to typical freeze storage conditions. Overrun and stiffness were measured as the ice cream was frozen in the batch freezer. Overrun is a calculation of the amount of air whipped into the liquid mix as it freezes. As can be seen in the chart, the overrun was quite similar across the four stabilizers. Stiffness was measured on a Stevens texture analyzer at the time of freezing but before hardening. Again, we see similar results for the ice cream with Aquacel GSH Cellulose Gum, guar gum, and the blends. These are the results for the melt profile study. Controlled portions of ice cream are placed on a screen and allowed to melt. A vessel collects the liquid as it drips from the ice cream and is then weighed. The graph depicts the rate of drip weight against time, over 2 hours in this case. As we can see, the rate of melt again appears similar between the ice cream with Aquacel GSH Cellulose Gum, guar gum, and the blends. First drip is the measure of the ice cream melt profile. This is done after hardening and conditioning of the ice cream. The ice cream is melted in a controlled process that we will see in the upcoming slides. As evidenced in the chart, the first drip was very similar between the three stabilizers. From the melt profile study, these photos show the portion of ice cream sitting on a screen and melting at ambient temperature. The liquid that melts and falls through the screen is what is weighed to give the numeric values of the melt profile on the previous graph. From the photos, the melt profiles of the ice cream are very similar for each of the stabilizers used. Ashland had an industry expert, Dr. Bruce Tharp, who is very well known in ice cream technology, evaluate the ice cream samples. He determined that the ice cream formulated using Aquacel GSH Cellulose Gum was comparable to the ice cream formulated with guar in terms of texture and control. The smoothness of the ice cream, as determined by ice crystal size, was similar across the control and test products. In fact, there was a slight improvement in mouthfeel from the use of cellulose gum, as it created a slightly richer body in the ice cream. We examined ice cream samples by scanning electron microscopy. The interpretation of the microstructure of the ice cream by our microscopy expert was that the size of ice crystals of all samples was limited to 1 to 2 microns, which is accepted as stable, smooth ice cream. At the same time, air cells were in the range of 10 to 50 microns, which is also characteristic of a typical ice cream. From this work, we can see that formulators have options. With the current pressures on guar supply, formulators can choose to reduce their guar use by blending with Aquacel GSH Cellulose Gum, or they may choose to replace guar completely with Aquacel GSH Cellulose Gum and deliver ice cream with good texture and stability.
In summary, the replacement of all or part of the Guar gum in an ice cream formulation with Aquacel GSH Cellulose Gum yielded comparable melt profile, overrun, and stiffness. An industry expert found no significant differences in texture and a slight improvement in body with the use of cellulose gum. Aquacel GSH Cellulose Gum is an effective replacement for Guar gum in ice cream. Just a reminder that Ashland is a world leader in cellulosic food ingredients. Our products meet our food formulation customers' health, convenience, quality, and processing needs in major food applications. We create value through applications knowledge, market insight, and a powerful product portfolio. To learn more about Ashland's food products, please visit our website at ashland.com or contact us by phone at 1-877-546-2782. Thank you.